Welcome to Coding Adventures. Did you enjoy the previous lesson? The one from yesterday about sprites? Yeah? You did? Well, that's great, because today we're gonna continue the discussion about sprites and learn about custom sprites, and I'm also gonna show you how I build this game using custom sprites. So, let's get started! Alright, so I'm here on my desktop and I loaded that game that I showed you before in the intro, here in the editor, and as you can see there is some code and I built this game using custom sprites. I had tons of fun building this game and I like to show it to you before we start the lesson. Alright, so give me one more minute to have some extra fun and play the game for a little bit, and you can watch and see the game. Alright? Let's start. So this is the game. It's called Push the Frogs. I couldn't find a better name. But it's a very simple puzzle time game. You have to basically push a series of frogs and find the exit in a maze. Alright, so let me show this to you.
Go!
As you can see, I'm moving here in this maze and I can push frogs around. Well, or I can put them in the corner where they remain stuck. I can only push one frog at a time, and I found the exit. Let me just go outside of this maze.
Objective achieved. Go!
I'm on level 2 already. Let's have some play with the frogs. Alright, it's time to go home. We'll go through here.
Objective achieved.
Alright, that was easy. Let's try another level.
Go!
Well, it's a little bit more difficult. Oh, not that difficult. You can still find the exit. And let's go outside.
Objective achieved. Congratulations!
I won the game. Alright.
Go!
So this is a simple game anyway. As you can see, there's still a work in progress and there's still other things to be done, new levels to be designed, perhaps even better levels, more challenging. Put the different obstacles, make sure that the frogs are in the right positions, and so on and so forth. But this from now on, it's not coding, but actually it's tuning the game. The reason I showed you this game is because also this game is made with custom graphics. It resembles one of those games from the 80s. It is, therefore I call this one a retro looking game. So resembles those games from the 80s, but it's built here in JavaScript. This is the fun part. It's built in a modern language on the codegrappy.com platform using custom graphics. And these custom graphics are basically everything that you can see here on the screen, like the frogs, this player, and even these walls, these bricks layers are built using custom graphics. Alright, so that was all for the game. Let's actually learn now how can we use custom graphics in our JavaScript programs. How can we design these custom graphics? And there are different ways. I'm going to show you different ways to design these graphics, including the most basic of them all, drawing them on paper. And I really mean on physical plain paper. Let me show you some images to see what I mean. As you can see here, these images were drawn by different people, and they're basically drawn on paper using nothing else but crayons. All right, and you can see very small sprites here. This is a helicopter and other sprites like that. You know, if you are basically this is a great activity for people of all ages. If you are a computer science educator, you can organize this kind of activity with kids in a club. But even if you're an adult, perhaps you can build really interesting sprites on paper. And in a way, this is how people used to do it in the 80s. All those famous games from the 80s were drawn basically on paper and then transferred into code. So that's what we're gonna do also today together. So before then, I like to share with you this game, the game that I built here. Just remember, we didn't build it together in the session, but perhaps one day we're gonna build it together, rebuild it from scratch. For now, I'm gonna just share it with you so you can inspect it and you know, have fun with it. So I'll put this on the chat. Push the frogs is there on the chat. You can inspect the code as I said, have fun with it, and if you're a little bit of an advanced user and you manage to enhance it, share back with me your enhancements, all right? So let's try to do right now ourselves some of these custom sprites that I showed you there, and let's do them on a paper basically. So let me look what I prepared for today. I prepared a paper with some grids here. Well, we can use also grid paper, and I also brought with me a bunch of these markers, colored markers. I'm not sure if we're gonna use all of them, but nevertheless I have them all here handy. So let me pick quickly one color. Perhaps I'll choose an orange one. And let me try to attempt to draw something here. I'm not a very talented artist, so perhaps I'm pretty sure that you can do much better job than me. But anyway, let me see if you recognize this drawing that I'm trying to sketch here. All right. I use these wiggly lines and it's not very clear. But in a second, hopefully, this will become more clear. 1, 2, 3, 4. Maybe 4. Yeah, let's do 4 here. So these are 8 by 8. And look what I'm gonna draw. Another one here, another one here, one here, one here. And let's repeat this pattern again. And do you recognize this thing? It's one of those spiders that we built together before. But back then, we built this spider without using any support from the engine. We actually built it using just an array of numbers, and we encoded them in the code. And we'll see that we can have basically a better way to kind of encode this kind of images into the code. All right, so this is one way to draw basically this kind of sprites. And if you're designing perhaps a game, you can think ahead of time. Well, in my game, you can say I need 8 by 8 sprites, or you can use 16 by 16 sprites, and a sprite is nothing else but an image, right? So these ones are 8 by 8, and you can print one of these papers that I have here and basically you know, draw your sprite. Now, I didn't mention what I have here on the left. With this new type of sprites that we're gonna use today, we have the choice of using up to 16 colors. So basically these are 16 colors for each of the sprites. So we're not gonna do them monochromatic like we did last time, but we'll actually use them, we use up to 16 colors for this, for any of the sprites that we are drawing. And then encoding of the sprites is pretty easy. So for instance, you assign numbers to the color. So let's say for this orange, we can assign a number 4 here. So when we encode it in the code, this means 4, 4, 4. And this empty, which is transparent, means 0, 0, 0, 0, and so on and so forth. Let me actually, you know what, I thought this one will be kind of small, so I have a bigger one here, just prepared just for you ahead of time. So the way I'm gonna encode it, we're gonna put a 0, 0 here, or you're gonna see we can put also a dot when we're gonna encode it, and this is basically the color that we want to draw. This one is still a monochromatic kind of sprite. It's still using only one color, but nevertheless we are encoding it this way. So here is 0, here it's a 4, here it's a 4, and so on and so forth, right? So let me go now switch to the code here and transfer this custom sprite inside the code. And I'm gonna transfer it first in a string, all right? So I'm here in the text editor, and I'm gonna transfer it in a string. So basically, what S, and I'm gonna use the multi-line strings. Remember the tick marks, so we can encode this on a different lines. And the way we're gonna encode it is for the transparent dots, we're gonna use a 0, or we have the option also to use a dot here, just like that. So we have 2 dots here, then we have number 4 repeated 4 times, and then 2 empty dots. Another empty square here, and then we have 6 4s. And an empty square. So basically, again, we are encoding exactly these numbers here. For each of the color squares, we are putting a number 4, and for the rest, we are putting a dot inside this string. So we are on the line 2. We are getting there. So it's a 4 4, a space, 4 4, a space, 4 4. That's 3 lines already encoded. This one, it's easy. It's just encoded like that. This one, it's encoded like that. This one, is like this. And I have one more, the same. Just like that. And now, all right, so I encoded this, basically this one, all the 8 by 8 rows and columns in this string, and we're gonna see in a second how we are gonna display this one. And one good news for you, we don't have to write the parsing logic like we did last time when we basically encoded this one in that matrix. And that's because the engine has already support for this, making this string in a sprite. All right, so we're gonna see how to do that. The way we do that, first of all, let's transform it from the string into an image, which is an image is like an it's an image object basically. It's an image representation of this sprite. So we're gonna say maybe sprite image, just like that, and we can use the function img of that particular and pass as parameter the string. And let's display this one on the screen first. So we're gonna use the function image. This is a function from the P5.js library that displays an image. Still, this is an image which is not yet a sprite. An image is what a sprite is made out of images, basically. An image is just something that you can display at a particular position on the screen, but you cannot move it, you cannot manipulate it like the rest of the sprites. But let's take baby steps and display this image just to make sure that we got the correct image inside, and then we're gonna see how to transform the image into a sprite. All right, so the way we're gonna display the image, we're gonna just specify the image here using the image function, and we're gonna display it in the middle of the screen at 400 300 coordinates. And now we have to specify a certain size. Let's run it just like that first. And look, a tiny spider in the middle of the screen. I'm not sure if it's visible on your side. Let's enlarge it. So we specify here 24 by 24. So sprite is 8 by 8 pixels, so 24 by 24 is 3 times bigger. So indeed, it's a little bit bigger. And let's make it even bigger. So it's 8 pixels. Let's make it 80 by 80 pixels. So it's 10 times zoom. All right, we have the spider. The problem is that the environment in P5.js automatically creates a little bit of aliasing around this kind of images, but we can specify not to disable that aliasing, saying here no smooth, because our sprite is kind of has very abrupt edges. All right, so this is our spider. As you can see, it's an image, and we created this image starting from a string, just like that. Now, there is another way we can create images from strings, and we are using a special form of this kind of new types of strings. So instead of having to do this thing here, what we can do, we can go, so let's name this one sprite image. We can put an img just in front of the string, just like that. No spaces, no parentheses, nothing. It looks like a weird syntax, and we're gonna discuss about this one in the future. But just remember, if you want to transform a text to an image on the platform here, what you can do is write the string using the the tick marks and put an img in front of it with no other spaces or parentheses or something like that. So let's see and run it again, and we have again the spider. So basically this one has the same effect as the one that we did before. All right, let me save this one, spider image, and I'm gonna save it here and share it with you on the chat. All right, spider image. And now we can go deeper in the code. But before we go deeper in the code, let me show you again how we better design this one, because I showed you just the first method on the paper. So I'm switching back here to my paper. And you know, this is a very good method indeed. If you want to design sprites on paper, if you want to re-experience the way people did it in the 80s, this is a great way. And you can basically print one of this paper. Here I have 8x8 sprites, or even if you plan to have bigger sprites, you can print one with 16x16. So I have here 16x16. I don't recommend to go more than 16x16 on paper unless you are a really talented, experienced artist. Otherwise, it becomes a little bit cumbersome and difficult to kind of do them on paper. But nevertheless, even using this method, I'm gonna show you a few drawings done in this method. I reprinted them. Look, this is a nice frog that basically was used in that particular game that I showed you before. It's again 16x16, was transferred to computer and back on the paper again. Let me show you another one. A nice flower. All right. And a strawberry. So actually these examples, you can find them also in a booklet. I can share this one with you. I have this one here. Let me just open it. And if you can see, I put all these ones in a nice booklet with several examples that you can use them if you are a beginner, and if you don't have inspiration, and if you don't want to design your own sprites, you can just copy and paste a few from the booklet. And as you can see, here we even have on the right the actual code snippet. We can copy it, similar to the one we did before with the spider. All right, so yeah, so designed on the paper, we just copied them from this booklet. There is another way to design these ones if you prefer a little bit more, if you're a little bit more technically inclined. If you go here on the CodeGuppy website, I built a program that I want to show it to you. So not in the editor, but actually on the website itself. I built in the past this program. Let me show it to you. And it's basically here on the site, Color Blockly. And this program, what it's doing, is basically a small tool that you can, let's pick a color here. You can draw something. Doesn't have a lot of functionality, but nevertheless, as you can see, you can draw this kind of sprites pretty easily. And what it does, it generates on the right the actual code that you can copy and basically put in your other program. So just like that. All right. So let me copy this one, and I'm gonna go back into a plain editor here. This is the this is the program with the spider. Let's create a new page, and I just paste that one. And if I run it, all right, we have a small balloon in the middle of the screen, similar to the one that, I mean, it's the same, similar to the one we draw there, is the same. And we can also hint a little bit of how to convert these to images, but I'm gonna show it to you step by step. All right, so you have 3 ways to design these sprites. You can basically design them on the paper, copy them from some booklet, and you can even copy them from my booklet, the one that I showed you before. I'm gonna share that with you. Or actually, you can copy them from other places, because this format that we are using here for custom sprites is common to Microsoft Make Code Arcade. Yeah, Microsoft Make Code Arcade. So if you find other places on internet with sprites in the format of this particular program, you can copy them from there. Microsoft Make Code Arcade again is the name. Or the third one, you design them in a tool such as the one that I showed you to you. You find it here on the CodeGraphy platform. Or if you are a really advanced graphic designer, there are plenty of other programs that you can use to design this kind of sprites. Just make sure to use those colors that I showed you on the left, and we're gonna discuss more about the colors in a second. All right. So let me go back now to that small spider program, because I don't have another one really available right now. Let me copy it, and I'm gonna start a new code. So just by doing like that, we are basically creating an image. We are converting this text to an image object, and we can place images in any point on the screen. And what images are doing, actually, they are basically drawing on that drawing layer. They are not drawing in the, let me show you the drawing layer again. They are not drawing as sprites. They are drawn in the drawing layer. And what we want basically, this is something that we may want, but these are affected by clear. So if we place, for instance, a clear here, this image will be gone. If we really want to have this as a sprite, we can convert it to a sprite. So let's see how we convert it to a sprite. All right. So I'm gonna remove this one. I still have the sprite as an image, but instead of displaying with the image, we'll convert it with a sprite like this. Let's spider equal sprite. We use the sprite command. And instead of the first parameter to specify a string, we specify the actual image. So this is the one. Then we specify a position where we want to display the sprite and the zoom factor. Just like that. And we have back the spider. And if you remember, this command is actually looking similar, is looking the same to any other sprite that you drag and drop from the palette here. The difference is that in the case of drag and dropping, we have this string which basically indicate a sprite in the built-in library. In this particular case, we pass a sprite or an image object, so we are basically using any image that we have here. For instance, one like this one. The rest of the parameters are the same, position and then zoom factor. All right, so if I run this one, we'll have both. But this one is, they overlap. Let's put them side by side. See, one sprite from the image library and the other one drawn by us. All right, so this is how we create basically custom sprites. We draw them somewhere, we transfer them in code as a string, as a text, and from text we convert them to image, and from image we convert them to sprite. And at this particular point, our sprite is just a full sprite that is no different than any other from the built-in library. For instance, let me show it to you. We can have a loop event here, and inside the loop event, we can have the spider move to the mouse, following the mouse. Spider.x equal mouse x, and spider.y equal mouse y. Pretty simple code, and we have the spider following the mouse. And if we want to implement falling spiders, we can do that as well. Or we can just, let me assign another property here, something that we learned yesterday. Spider rotation speed equal 3. And now the spider is following the mouse but is rotating continuously. And this is because of the game engine that does this renderization for us automatically. All right. So yeah, you can use basically whatever we learned about sprites yesterday. You can basically change their position, you can change their rotation speed, velocity, collisions. All those things work with custom sprites as well, which is great. Okay, so let's create another example here. So this is Spider 2. Share this one with you. And let's create a little bit nicer example, shall we? Spider 2. I told you that I'm not good at graphic design, but I do have a few sprites already selected. I have some sprites that I extracted from the Microsoft Make Code Arcade platform. So let me take these sprites really quickly. I opened them as text, as you can see, basically. I have them on my desktop, already prepared them. And I'm gonna paste them now into the code. All right, so let's inspect the code for a second. What do we have here? Let shark1 equal img, again same syntax, and then between the tick marks we do have some kind of drawing. It's not 8 by 8, it's not 16 by 16. As a matter of fact, I think it's 32 by 16. I can tell, we can count out the dots if we want to. But the main point is that these sprites are not limited to these dimensions. You can create even bigger sprites. You can even create them in the code. For instance, if you encode them wrongly on the paper, you know, if you are in the code here, you can just change it and encode it directly in the code. Or you can even try to encode them from zero in the code, although that's a little bit more difficult. All right, so we do have 4 different images here. Let's transform them to sprites and let's see them. All right, so the way we display them, we say for shark equal sprite. Let me zoom in a little bit, and let's put shark1, and then let's display it in the middle of the screen and perhaps a zoom factor of 3 because they are a little bit big anyway. All right. Look, we have a shark in the middle of the screen and it's quite a nice shark. I told you I cannot design this kind of graphics myself, but there are plenty of these graphics on internet if you are intending to basically build this one. So let's put a comment here. Graphics from Microsoft Make Code Arcade. This is the platform basically from which these graphics are. And if you are extracting graphics from other platforms and using them in your program, check please the license. Make sure that you are allowed to basically extract these ones. All right. So we have an image on the screen, but there is more to this custom sprites than a static image. The 4 sharks that I have here, well, we can view them individually like that, but they are not meant to be viewed independently or basically use them as independent sharks, because in fact there is a single shark that is animated and all these 4 images are different frames of the animation. So if you create a sprite that is animated, perhaps in this particular case it will be a shark that is moving, all you have to do is in an array specify all the frames. So in our case the frames will be shark1 to shark4. So let's put them, all of them here. And this moment, the shark variable will point to an animated sprite, hopefully. Let's see it. All right, it's animated indeed. And it's so cool. And we created this animation just with some text inside the code. There are no external resources, nothing associated with this program. As a matter of fact, if we printing this out and give it to somebody and then typing in, they'll achieve the same effect. We don't have to pass any other files together with the program. All right, let's have then some fun a little bit with these sharks. Since we created this one, let's have a little bit of fun with it and place multiple one on the screen, let them swim around, and this will give us the opportunity to practice more the coding concepts, perhaps arrays and animations and things like that nature. All right, so let's restructure a little bit this code. First of all, function, maybe create shark or make shark. Let's have a function make shark. First of all, we'll place all this code inside that function, and what this function will do is basically will create this shark object, shark sprite, and will return it just like that. All right, so now because we have this one as a function, we can invoke it. Well, we can also ident it a little bit if we prefer. Let's invoke it, make sure the program still runs. make shark. All right, we have a shark. The shark is pointing to the left. So let's make here, let's pass to this shark perhaps a direction. Or we can have also these sharks already animated to also move. So from within the function. Well, yeah, we can have them like that. Or we can animate them afterwards. So let's create really quickly an array of sharks. So perhaps make sharks. Not one, but multiple ones. We're gonna create an array, AR sharks. We're gonna create like an empty array here. We can also create one of those fancy structure like a group if we want. We can do that as well. But we can also use an array, it's fine. So let's create how many sharks? Well, we want n sharks. So we're gonna use a for loop. For let I equals 0, I let that less than n, I plus plus. And inside, all we have to do is to call the make shark function, because this one is creating we encapsulated inside this function all the logic, even the images, the custom images, and also the logic that returns a sprite. So this one shark, it's a sprite right now. We're gonna add it to the structure using push. In an array, we can push object at the end, basically. We can use the push method. And now we can return here AR sharks. Right, just like that. And let's have a global variable here actually that will keep all the sharks. We're gonna say make sharks, and let's start with 10 sharks on the screen. Just like 10 sharks for the beginning. Well, the problem is that they are all in the same position, but we can change that. So after we return a shark, we can change the position. Shark dot. Actually, let's make the make shark accept an x and y. It's much easier. So in the moment we create a shark, we can create it here, not at 400, 300, but at x and y position directly, right? So when we're gonna create them, we'll say make shark at a certain x and y, basically random. So let's pass directly here some numbers, random of 800 and random of 600. So at any position on horizontal or any position on vertical, so we're gonna create these sharks. There are 10 sharks swimming happily. You know what? Let's also make them face either one way or the other way. So basically this one will be the direction, and we're gonna use a mirror x. So we're gonna use a mirror x for that. So this one will take a direction. Let's also extend the function just to return the shark already mirrored into that position, and we don't have to mirror it outside. So what we can say here is shark mirror x. We can put that direction, and then we return the shark. So we make the shark at this position and then a certain direction. And let's have a variable for direction, which is a random number, either -1 or 1. A random number between these two numbers. It will pick a random between this array. So let's see how it looks. All right, some are facing left, some are facing right. And now let's make these sharks swim. Swim in the ocean. Perhaps we should even choose, this ocean theme, we should choose it for the sharks. Make it a little bit more realistic. Let's put it first line. All right. Let's make them swim now. Yep. How can we do that? Well, we can change the x coordinate in a loop, or we can just set velocity and then they just go into that direction, right? So we can set the velocity. Yeah, let's just set the velocity basically here. So we'll also put it encapsulated in the function. So the return shark is already a moving shark. So we're gonna say shark velocity dot x on the horizontal equal. And now let's see, perhaps we should have, let's make them swim at random speeds. So it's a random between, velocity 1 and 5, something like that. 1 or 3. Some sharks can swim up to 3 times faster than others, not 5 times. All right, so that should be all. There is a problem. These guys are not swimming right, and there is a good reason for that one. The velocity should basically reflect the direction. So I think we should multiply direction, which is -1 or 1. So if they're swimming to the left, we should get a velocity, a negative velocity there, basically. And now they're swimming backwards, but correct though. So it's the inverse of that one. -1 times direction times that number there. All right, they're swimming right. And now they leave the screen. Bye bye, fishes. Let's take care of that aspect. Let's not let them leave the screen. And until now, if we are looking at this code, these sharks and this decor and the entire shark tank. Oh, that's a good name. This is a shark tank. All the sharks are just moving without us to write code for movement. In a sense, this is declarative coding. All we had to do is basically set these properties here, the mirror property, the velocity, and this is because we have an engine, a game engine behind the scenes that are reading these properties and is moving the sprites for us. But now we're gonna write the first kind of imperative code that we're gonna check where the sharks are, and if they reach one side, we're gonna make them go the other way and so on. So let's write a function here. And we're gonna use the function loop that is executed automatically, like we said, by the browser 60 times per second. So inside this function, all we have to do, we're gonna loop through all the sharks. Let's count the sharks. Let shark of sharks. It's very easy to loop through an array using this for of syntax. So now we can say if shark.x is greater than 800 or shark.x is less than 0. Basically, sharks are exiting the screen in either directions. All we have to do is basically, we have to do two things. We have to mirror them and also inverse the velocity. So yeah, perhaps we should, these sharks, they should also have a hidden property here, the direction somewhere. We should store the direction. Yeah, let's store the direction, will be a little bit easier. So we're gonna create a property dir or dir on the shark, and we store that particular direction that we are giving to them. And as I mentioned, we can create properties dynamically at runtime on objects, so we can do that. So now if they are leaving the screen, what we can say is basically shark dot, we can copy these two lines. We can make them mirror, so that the direction is basically shark dot dir this time is the direction of each individual shark, and then we mirror them and we mirror the velocity. So it's either this one or totally reversed. So let's see them. Once they hit the screen, oops, they don't come back. They don't come back. What's happening here? So let's see. Perhaps it's the other way. We start -1 now when we change the direction. Yep. But the mirror is with -1. It should be like this. Let's see. Let's watch this guy. He's hitting. Now it's going fine. Let's see on the other side. Oops. Did we lose that one? I think we are losing them on the right side. Oh, we lost them also here. We lost all the sharks. What's going on here? Let's see. We are inversing the velocity basically, which basically the shark should go in the other way. And oh, first of all, we don't have to assign them a different velocity. They can come back with the same velocity. Why not multiply this by -1? Why do you have to keep the direction? Let's check just a second. Yeah, this one is going fine. Yeah. We don't need, well, just for the mirroring we need it. Although we can extract the sign from the velocity. Well, it's fine. So let's watch a little bit our Shark Tank. Yeah, it's really cool. Do you like it? Perhaps now, oops, but no, it's not right. Sharks are swimming backwards. They're swimming backwards for whatever reason. So is the direction here? This one comes back? No? We have an error in the code. Let's see. So the velocity, we reverse the velocity, but then the direction, we have also to inverse the direction, of course. Of course. Shark.direction, let's do it like that, is -1 times shark direction. And now, of course, and now should be fine. Oh, so many trial and errors. Yeah, they are fine now. Finally fun. Our Shark Tank is ready. So now perhaps we can put some music and put this on a big screen TV and enjoy our our tank with fishes. Or what we can also do, we can transform this one in a game. Perhaps we can make the, one of those games that you find in arcade rooms where you have a person sitting on a boat and tries to fish some of the fishes in the ocean. We can easily transform that one. We can place here some sort of a rectangle and we move it with the mouse. Or why rectangle? We can define the boat using a custom sprites. All right, but yeah, that will be a little bit of too much work. Let's try though to make the shark sense if the mouse is close to them, right? So we are iterating to all the sharks. This one is just to take care of the flipping of the sharks, and now we want to verify something else. We're gonna verify the distance between the shark and mouse. So the distance is basically, if you remember, it's using the dist function. So let's take it in a separate variable, in a variable d, the distance between shark.x, shark.y, and mouse x and mouse y. And we can say now if the distance is less than, I don't know, 30 pixels, something like that. For the moment, let's print something on the screen. Close. Let's see. So let's go close to a shark. Yep. So what can we do in this case? Well, obviously, we can play a sound. That's one thing. But I want to show you something else, and that links into more capabilities of custom sprites. Let's make the shark kind of try to bite into the mouse cursor. All right. So we're gonna do this. Let me go back to my file here where I saved the shark, and inside here I copied shark 1, shark 2, 3 and 4, but we have more images saying shark attack 1, shark attack 2. So let me copy all the rest. Like there are 6 more frames. This one for a shark that is attacking. So what we're gonna do, I copied those. I'm going inside the code here. Let me first place them just here and just to have them in the code, and then we're gonna see how we utilize them. Okay, and I'll ident a little bit the code. All right, just like that. Now let's look here. Until now we saw Sprite, again, a small recap. We saw it with a parameter of type text, with a parameter of type image, and with the parameters of type array, in case we have an animated kind of sprite. But we can also have sprites with multiple animations inside, similar to the built-in sprites. Like for instance, this one, see, this particular sprite has multiple animations that we can change at runtime using the show method. In the same way, we can construct sprites, custom sprites with multiple animations inside. And in order to do that, basically we'll have to use a small object to define this structure. So let's define a small object. Let's name this one OShark, object shark. And if we remember how we define objects, are basically using the curly brackets like that. And this object needs to have as many properties as there are animations. So in this particular case, we have two animations. We have a swim animation. So basically the shark is swimming, and then we have an attack animation. So the shark is trying to attack something, right? So we're gonna define this object that has, again, two properties, swim and attack. And each property takes an array, basically the array of frames. So instead of this array here, let's move this array inside here. So this is the array of frames for the swim animation. And now, similarly, let me copy one of these variable names. Similarly, we need an array of frames for the attack animation, and I think there are 6 frames here. We can double check really quickly. Shark attack 1, shark attack 2, 3, 4, 5, 6. Yes. Apparently there are more frames for the attack than for the swimming itself. So there are 2, 3, 4, 5, and 6. Alright, so, and now what we're gonna do in the sprite function, instead of that array of frames, we're gonna pass this object. Let's see what's happening. I'm gonna run it, and basically the code is the same. Let me save it, just not to not to lose it, just in case I do a mistake. And the reason is the same is because we define this structure, and we define, okay, this sprite has 2 animations. One is called swim, one is called attack, and these are the frames for each animation, but the engine automatically picks the first animation. In order to show the second one, we're gonna use the .show method, similar to this kind of sprites here, like we see here, .show idle, jump, run. So we're gonna say this time, .show attack. Alright, so we have swim and attack. So let's get back in the code here. So if the mouse is closer than 30 pixels, we're gonna say shark.show, and we're gonna put here attack. And actually let's put also the else branch, because if the mouse is further away, we need to revert it back. Let's not revert it back, let's see it how it behaves. Alright, I'm getting closer to a shark, let's say to this one. Alright, the shark is attacking but remained attacking. We need to make it back, so if the distance is no longer closer than 30 pixels, let's put that else here, shark show, and the other animation is swim. Okay, so if I'm close, the shark is trying to bite the mouse cursor. If I'm far away, the shark is just behaving normally. And it's just going the same with all the sharks. See? Perhaps we can also draw some sort of a small thing around the mouse. So, okay, let's extract this in a function. All this code that we wrote until here. This one is function update sharks. Yeah, update sharks is fine. Sounds like a good function. And we'll call it from inside the loop. And let's create another function here, update drawing. Update drawing, basically the drawing layer, this guy here in the middle. That on that one we're gonna use the circle instruction to draw something around the mouse cursor. So let's create that function. So what we have to do here, we're gonna clear the drawing layer for each frame, and then fill. Maybe perhaps we should fill with green. I don't know, what kind of food sharks eat? Fish. There are no green fish. These are vegetarian sharks. So we're gonna use a circle at mouse X, mouse Y, and perhaps 10 radius. Let's see it. Alright, so we have a small dot around the mouse, so the shark is trying to eat this one. Oops, didn't hit it. So, you know, we can create one of this game, feed the shark perhaps. We can pick up some food. Once the shark is eating, the food will disappear. We have to pick up another food, and then we have to feed all the sharks. That will be fun. But I leave this as an exercise to you. For now, I'm gonna just share this one with you. The Shark Tank. Any resemblance to real life is pure coincidence, I guess. Shark Tank. All right, the program is there on the chat. I hope that you like it. Before we moving forward, actually we covered pretty much everything for the day, but I want to recap a little bit what we learned about the Sprite until now. All right, so it's a good time for a recap here. So I'm here on my notebook, and let's write for a second basically how we define a sprite in the code. We use basically the sprite function, just like that. And then in between parentheses, we have to specify the first argument here. And then here will be, for instance, the coordinates, like we put 400, 300, and perhaps a 3 here. All right. So that's all it takes to create a sprite. And this one will return it basically. So this one is returning the actual sprite. So let's understand again what we put here. Until now, we put just a string, but there are actually different things that can go inside there. So number one can be a string similar to, let's say, Dino idle. I'm making this up. I don't think we have a built-in sprite in there. We can check together if we have one. But anyway, if we are putting here a string, basically we're gonna use a built-in sprite. So that's one way to basically define a sprite. And this is again for the built-in sprites. And built-in sprites are really, really good for actually learning to code. Since you are not focused on finding sprites on internet in order to just play with them, you just pick one from the library there and run your code and create code around them, create mini games, and you have fun and you're learning to code. Are great for this purpose. Okay, the second type of information that we can put here, we can put an image basically. And we're gonna see in the future how other ways to create images. Today we saw basically one way to create an image using this format, basically img, and between tick marks is basically we put those, you know, the spiders and so on so forth. So this is a way to create images basically from this kind of strings using this img syntax, and we're gonna discuss about this one more in the future. But the result of all this kind of command here, it's an image object, and in the moment we assign an image object here, the engine it's intelligent enough to know that we are basically need to create a sprite not from the built-in library but actually from an image. The third kind of information that we can pass in there, it's an array of images. So it's img1, img2, and so on. And what this one will do, it will basically create an animated sprite. And it's exactly like with the shark that we created today. All right. And the fourth type of information that we can pass, it's actually an object with basically different animation, perhaps animation 1, animation 2. You choose the name of the animations inside the object, but for each of these you have to basically construct the object in such way that you pass the frames independently for each animation. And once you construct its object, you can also pass it, so this information also go in here, and this one of course also can come in here. All right, so once you do this thing, the sprite command will gonna return a sprite. And today we saw basically sprites created from using this third last methods here, and yesterday we saw using the first method here. All right, as you can see, although it's pretty simple, it's also a powerful way to design custom sprites And if you are an artist, you can have tons of fun. If you are not an artist, work with a friend, somebody, you know, maybe make a pair team. Somebody will design the graphics of a game, and you, because you are the coder, you're gonna write the code and you're gonna create a beautiful games. Or animations, or something that you can share with friends, or a Shark Tank that you put on your big screen TV in the living room with a nice music, and you can put a big title that is made by you. So yeah, I hope that you like this this exercise. Let's talk a little bit now about that palette that initially when we build the sprite, and let me pick one of my papers here. Yep, perhaps this one, or we can pick another one, or this one. Let me pick another one, or these two here, right? Or the one with the frog. I have all of them here. When we designed these sprites, basically, we saw that we had to encode inside the code certain numbers, which are these numbers here, right? And you can also see here some colors associated with this. So basically what you see here, there are 16 colors, first of all. If you are creating images using this IMG and then tick mark syntax, these images accept this format, basically a string with these numbers inside. So basically you can create images up to 16 colors. And you may say, okay, but 16 colors are not that much in today's world of true definition and high definition displays, but actually there are a lot. And since you are designing these sprites alone, maybe on paper or directly in the code, if you have more than 16 colors, it would also be more difficult to design them. 16 colors are plentiful enough to create nice looking games, perhaps a little bit retro in style, but nevertheless can be pretty nice. And the colors that you are using are this one that I'm showing here. So you have a red, a pink, an orange, a yellow, a blue, and so on. But you are not limited to this one. You can, and these 16 colors are what is called a palette. So 16 colors, this is called a palette. All right. But you're not limited to these ones. You can design new palettes. So if you don't do any operation to change the default palette, this is how the images will look like, right? If you put basically a 7 somewhere, like here, well, that will be appear like a green, because we have one green here. Now, if you are not happy with these colors, and if you want a different set of colors, you can do that as well. We have an option basically that we're gonna learn together how to change the colors of the custom sprites. But for now, let's see the custom colors here in a program, and also this one will give us the chance to practice for loops a little bit. So, okay, this program is saved. We can start a new one here, and there is a certain special command in here called get palette. So let's invoke it, just like that, get palette. And what this one is returning, it's returning an array. So let's print this array. And if we'll print it, it's a little bit long. Perhaps we should print values one by one. It's much easier. For let I equals 0, I less than ar.length, I++. I'm using the other syntax of for because I also want to display the I inside. So let's use a println here. Let's put an I, a space, and then put AR of I. So let's print these values. As you can see, there are some colors. If you remember from the lesson about RGB colors, these are in the format pound and then RGB, each one written in a hexadecimal format. But anyway, what getPalette is doing is returning the current palette. And if we are running this function, we'll see that this basically it's just an array of colors, and more exactly 16 colors, because there can be only 16 colors per palette. So let's do as an exercise and actually display these colors, and then we're gonna see how we can change the palette. But before we change the palette, let's display them, not as a text, but let's display them as some rectangles colored appropriately. All right, so what we have to do here is there are 16 colors, right? So we have how much space we have on vertical, about 600 pixels divided by 16, maximum 37, perhaps 20. We can make a rectangle 20 pixel high and we leave a little bit of a space in between, perhaps 10 pixel in between. So let's have an x coordinate, which is basically, this moment doesn't matter, x is constant and we just go on vertical. And y is basically the I value times 20, I plus 10. Let's see. Let's place I times plus 10 times 20. And then let's have a rectangle and x and y, 100 pixel width and 20 pixel height. We'll see. Oops. Yeah, it's not I plus 10. What I'm doing here? It's I times 20. All right. So well, we can multiply them by 30 and then we can have that one. So it's 10 plus that space. So that should be okay. We should have 16 colors here. We can even make them a little bit further apart. I think we have plenty of space. 1, 2, 3, 4, 5. I think there are not enough space. There is not enough space. Make up 35 pixels. We should have calculated mathematically. But anyway, these are the rectangles, and let's fill them with. We're gonna fill them with AR of I. There is only one. Yeah. The first one was empty actually when we displayed them with println, and that's empty means transparent color. But anyway, fill apparently if it's empty, just displaying it like that. So let's also write a text next to them. So we'll have an x plus 120 and y. These are the coordinates, and the text itself it's AR of I. Like that. Let's yeah, and we also draw the text apparently here in in the color of the fill. We can draw the text in just in black. So let's fill it with black and have a no stroke here, and these guys will have a stroke of black, the rectangles. All right, so this is the current palette basically that we are using. These are the colors and these are basically the colors, and let's display them also a little bit of a number before in front of the colors. So why not have another text? Yeah, let's have another text which is actually the I. We want to display I at x. Actually, let's display it as 0. Yeah, so these are the colors, and look, there is a certain trick here. When we are displaying a number, we can pass it like that, or we can use the toString. We discussed about the method last time, which is displaying the the number. It's converted the number to string just in that moment. But there is another way. There is another option to the toString. We can specify a radix or a base in which the number will be first converted. So I'm converting to base 16, which basically displays the numbers from 0 to f, because these are the numbers that we have to encode inside. All right, so as you can see, this is the default palette. So let's name this one default palette. And I'm gonna share this one with you, just in case you want to see the for loop basically, and there's not much else to see here, but nevertheless, default palette. The program is on the chat there. And now let's see how we can change the palette. And the way we change the palette, it's basically using set palette. And what we have to do, we have to specify an array of colors, right? So let's not do this one in here, but actually let me locate really quickly the program with the spider. Yeah, this spider, right? So the spider is drawn in this color, because on the position 4 in that default palette we have that particular number, that particular color. But what if before this we're gonna use the set palette and we're gonna design a palette like this. Let's say the first color is transparent, empty string, the second color we don't care, the third color we don't care. Actually, you know, see, this spider is actually monochromatic. There is no way to use, no need to use a 4. So if we are designing a custom palette here, we can replace 4 with 1 and just have dot and 1. But anyway, so 0, 1, 2, 3, and perhaps this is red 4. All right, so we have a red spider, and in this particular case, I defined the palette with basically 5 colors, because our sprite anyway is using just one color or 2 colors. One is transparent and is using the other one for displaying. So in our case, would have been enough to have a palette of 2 colors, but then we have to put here number 1. So you don't have to define palettes with 16 colors. You can use even less than 16 colors. Or pick here any other shade, maybe Indian red or some other colors that you want, or define one that it's in RGB, whatever you prefer here. I don't know, let's choose this color. Okay, this wasn't in the original palette, but as you can see, you can define new palettes in this way, just like that. All right, so that's how you basically also define new palettes. And like as I mentioned, this one are pretty easy to use. You can just use the knowledge that we learned yesterday, but let's practice a little bit more, shall we? Let me pick, because I saved here a few of these nice sprites that I found around. Yeah, let me pick this one, a flower sprite. And you can create collections yourself. So basically, if you are designing games with custom sprites, just you'll have a collection of growing sprites that you can reuse them. So let's have this one. First of all, let's visualize it. Let's say let flower, and I can use it directly without having an image and then having to create a sprite. I can just use it like that, just like that. I just need to pass extra arguments to the sprite, so where to display it and what zoom factor do we need. And since these are pretty small, I'm using a 3. Yep, that's a flower, a pretty flower, right? So let me pick an image also. It improves so much the quality of our programs if we pick nice images. Flowers, a summer one perhaps. Yeah, the summer, it's called summer. Okay, let's pick this one. And oops. And okay, we have a flower, but let's create a plenty of flowers. Maybe rain with flowers. The summer everywhere is raining with flowers. I guess. So the way we're gonna do this, we're gonna create a number of sprites, right? And yeah, let's create an array like we did last time. Flowers. It's an array of flowers, and now we're gonna create the flowers. A function create flowers. How many? N. And these flowers will be created at random positions on the screen. Actually, let them create them outside of the screen. So random on horizontal. And on vertical, it's a random number between -600 and 0. So exactly like in the exercise from yesterday, we are having an off-screen screen entirely there. And they can have this zoom number, right? Also, this flower, we're gonna set flower.velocity.y equal a random number between 1 and 3. So the flower will start going down automatically. And let's also set a rotation speed equal 1. All right, but we have to create more than 1. So we're gonna put a for loop for let I equal 0, I less than n, I plus plus, and All right, so we are doing that. And you know what? Rather than having an array that we return, we can just access the global flowers here directly this time. It's okay. So after we set all these properties, we're gonna say flowers push flower. All right. So now we have to invoke the function. We're gonna say create flowers, 10 flowers, and let's run the program. Oh, this was the program. All right. See, it's raining with flowers. Let's then make them stop at the bottom of the screen. So the way to do that, we're gonna create a function loop. Let's iterate all the flowers for let flower of flowers. And now we can check if flower.y, we can check for each flower if they reach basically the bottom. So maybe if they are past 550 pixels, what should we do? Should we just stop it? Right, so we should set the velocity to 0. So basically the flower should stop at that position. We are not removing it, we are not, you know, not recycling like yesterday. We just make them stop there at the bottom of the screen. And let's watch them fall. All right. Perhaps we should stop also the spinning once they reach this position. Because right, they are resting on the ground. Let's do that as well. So it's maybe also here 670 and flower rotation speed equals 0. All right, so this is flowers. Save, run, and enjoy. All right, and they stopped also spinning once they hit the bottom of the screen. It's cool, right? 10 flowers. We can put more if we want. 20 flowers. You know, at this point we can even turn it in a game. Perhaps we can have a person running at the bottom, collect the flowers like we did with that plane that was raining coins, and we collect them. So you know what, you can take this particular code and merge it with the one from yesterday with the plane and combine them. And you know what, you can actually combine also sprites, built-in sprites, with this kind of custom sprites in the same application. So perhaps you can make that plane drop flowers, not coins. It's up to you, up to your imagination. But if you create something interesting, share it in the chat, please. So let me share this one with you for now. So this one is flowers. All right. All right. And what else can we discuss today? Another important concept that we discussed yesterday, it's collisions, right? So actually, let me go back into this program with the flowers and take that code that creates the flower, this one, create flowers, but we're gonna go in a blank code page, and we'll not make them rotate or fall, nothing of that nature, and we'll actually make them stay on the screen. So it's random of 600 here. All right, so we'll have a let flowers and an empty array, then we're gonna fill it saying create flowers, and we're gonna put 10 flowers on the screen. They just sit here. We need also a nice background image because everything looks nicer with the next background image. What is appropriate? Flowers in the desert, yeah, in the forest, big mountain, grass, summer. Any of these images, I think it's appropriate. Let's pick the forest. Of course, it doesn't matter for the code. It's just for our own impression. And if you want to impress your friends, put a nice background, then the program will look 10 times better. All right, so we have all these basically flowers here. And let's say, let's have another sprite, shall we? That is moving with the mouse, really quickly with the mouse. So let me see if I have anything handy here. If not, we're gonna invent a shark. A shark eating flowers, that will be funny. Yeah, let's pick perhaps, I have a heart. Yeah, we can, no, let's go on that custom sprite brochure. yeah, let's pick this girl. Let's say this person is collecting flowers. So this one, let's put it in a function create player, and what this function will do, we'll ident them a little bit, and we're gonna return a sprite created from my image, and now we have to specify where to draw it. We're gonna just put middle of the screen for the moment, and a zoom factor, also 3. We can change this one later. So let's call this one create player, just like this, and we have a player in the middle of the screen. But what we can do, we can have a function loop, and inside the function loop, oh, so this one is let player equal, we can have player.x equal mouse x and player.y equal mouse y. So we make basically the player following the mouse cursor. As we move the cursor on the screen, the player should basically, the sprite will just move there. So let's see if we are right. All right, so it's moving around. It's not a kind of a game, because we can collect very easily the flowers. We can just zoom, 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 zip around the screen, and we'll collect them. Perhaps using keys will be a little bit more challenging, but anyway, for the purpose of the demonstration, is good enough. We want to basically talk about, like we mentioned, about collisions, right? So let's see how we can create a collision between player and flowers. Also, let's move the flowers here actually in a group. Let's say new group. Which we say it's a little bit better when we are talking with group of sprites than placing them in array. The engine will manage them a little bit differently, but if we are using a group, we have to say here add instead of push. And a group is kind of an array, like in a collection. All right, so what we have to do inside the loop here now is to basically check for the collection, right? So we can say player.collide. That's what we used yesterday, and now we can also loop through all the flowers and check if we are colliding with a particular flower, or it's easier because we have them in a collection. We can just put here flowers. But you may wonder, how can we know which flower we collided with? Well, I want to show you something that we didn't saw yesterday. This collide function, we can use it like we used it yesterday. Either saying here if player collide, then do something here. For instance, we check if it collides with a flower, but we cannot put an array, but we can put, or we can put also an array, but we'll not know exactly to which flower we made a collision. We can use it this way, and here perhaps we can say remove the flower. We'll have a hard time to know which flower. Or there is another way in which we can use collide. So without that if, we can specify here, and you'll see a second parameter. But for that, let's create first a function on collision. Let's call it this one on collision, just like that. Player flower takes these 2 arguments, and it's a function. We said we're gonna create it as a function, just like that. And inside we're gonna put a println just to make sure this function gets invoked. And now we specify to the engine if, look, we say like this: if the player is colliding with flowers, invoke this function. So the way we say invoke this function, we put the name of the function in here as a second parameter, but we don't put it as a string. Notice there is no quotes around this one. We just put the name of the function. And in JavaScript, this is a specialty construct. We didn't encounter it until now. Maybe we'll have the chance to encounter it in the future in a more advanced lesson. But for now, just take it as is. If you want to check for collisions, you can specify a second parameter, and as a second parameter, you put there the name of a function. And then the engine will automatically, we expect the engine to automatically invoke this function each time the player is colliding with any flower. And we are basically invoking this function. So let's test it. If everything works correctly, we should see a line D being displayed because of the println line. All right, so let's see it. And oops, okay, actually it's quite good. We have the test there. So we are in good shape. The engine invoked indeed the function. We don't need that if in front here. Now all we have to do, and also more than that, this function has a special format, can accept parameters being the player and the flower. So basically the two things that are getting to be colliding, right? So what can we do in here? First of all, we can say flower.remove, a pretty simple thing like we did yesterday, and we are removing the flower. Basically we are collecting it, like just like that, and we can increase the score. Boom, 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 and that's working. Or you can set the velocity upwards and the flower will fly away. Also, basically, we are collecting the flower. Let's put also a nice sound here. Let's see what we can choose for sound. Perhaps, yeah, this one. It's not a space trash kind of sound, but that's the name of it. Doesn't matter. So let's see how it looks like right now. We'll run it. Let me run it again here. Is working, and we can have that score, we can increase the score and so on. Also, other than remove, what we can say is set a velocity dot y equal -10. Yesterday we used to set also velocity on x, so it go in diagonal. Let's just say it set on the y just to go on vertical. And we are collecting flowers here, and I don't want the sound at this moment. So we can basically, yeah, collect flowers just like that. And we saw another method to achieve collisions. And this is very useful. You can imagine your game. So in the game that I showed you before with the push the frogs, basically the player was always checked against collision with one of the frogs, and basically a decision was taken there. So that depends on the game. All right. So this is and this kind of collisions, of course, these being sprites, it doesn't matter where they are coming from, if they are custom sprites or if they came from the built-in library. These particular methods and capabilities of manipulating sprites, they are applicable to all types of sprites. All right. So at the end of the day, they are the same kind of sprites. They just come from a different source. All right. So we still have a few minutes for today. Let's try one more example. I'm not sure if we'll have time to create a full kind of one, but let's at least try one more example, because I extracted here some some nice sprites and I want to use them really quickly here. So let me put this one in the code and see what we can come up with, just starting from these sprites. All right, so I have two sprites. They're from a ship. They're frame 1 and frame 2. So yeah, let's take them into variables first of all. Let's name this one ship 1, and this is an image. We convert to an image using this format. We close it here, semicolon. Oh, come on, semicolon. And this is let ship 2. This is an image. We'll open here, we close here, and this is ship 2. Let's get rid of this text to make the code valid. And let's create a sprite out of this. So it's basically a sprite. We're gonna use an array because it's an animated sprite. So basically ship 1 and ship 2 are the two elements of the array, and we're gonna use it in the middle of the screen and assume factor of 3. And if we run it, yes, it's indeed a ship. So let's encapsulate this code in a function make ship, and this one will return the actual sprite that is created. And let's ident them a little bit, just like that, and make the ship at an x and y coordinate, perhaps, just not to have the 400, 300. We can leave the zoom factor 3 here, or, you know, if we want a really big ship, is 10. but we didn't invoke the function. So let's invoke it here. 400, 300. Now we have to specify the values. So this is a big one, but it's kind of chunky since this sprite is not that big. It's even smaller than the shark sprite. So a zoom factor of 3 makes it look a little bit cuter. Yeah, and one more thing. Let's have it also background. Let's make it black. This is a, you know, it's a deep space ship. So, yep, just like that. All right, so let's recap some of the things, how we can control the ship, moving it up and down and so with the keyboard. So inside the loop, what we're gonna do, function loop. I'm typing so bad today, I don't know why. So let me say here, take it in a global variable. Let ship is make ship, and inside this loop we can check if key is down. Let's remember, I don't remember the format, but we can check here, key is down. If key is down. And again, one another way to verify this one, for instance, this is coming from p5.js, so it's basically keys down p5.js. You can Google this one, you'll go to the reference, and you can also read here about the keys down, and there is some more information here about this function as well. All right, so we're gonna use keys down, so we're gonna check if it's left arrow, we'll do something else. If key is down of right arrow, we should do something else. And let's check also if it's up and down this time, right? Up arrow and down arrow. And let's have a constant here, speed equal 3, just to have it. We can have it const. The ship can be a const because we are not changing it. So if it's left arrow, what we are doing? We say ship dot x minus equal speed, right? And then if it's right, we are using plus equal speed. If it's up, we are decreasing y. And if it's down, we are increasing y, like that. Let's see. All right. And we can have the ship move on the screen, and now we can have, if the ship is and see, the two frames makes the ship a little bit animated. The flame is a little bit different between the frames, and sometimes when you are designing animated sprites, you don't have to just imagine each frame is totally different. Just make a few modifications, change a few pixels, and when you are running it, it looks a little bit nicer being in an animated format. All right, so this ship now can shoot some missiles or can drop coins. Anything is possible, and we can extend this game, but I don't want to do this right now. I want to, this black is too black. It's like there are no stars. Well, we should have stars in space. So let's create some stars. And although this lesson is about custom sprites, we're gonna make a parenthesis and create some stars with some using point instruction. All right, shall we? All right, thank you. Let's create some stars. Let's have a function like we have make ship. Let's make it at the end here. Function create make stars. How many stars? We take an n as an argument, and all we have to do, we're gonna have a loop I less than n. So we are creating n stars, and actually we are not plotting them directly on the screen. What we are doing, we are placing some random numbers in an array, and then we're gonna create a similar function to display the array, right? So this is a function to make stars, and then we should have one display stars, like that. Let's say this one takes an array of stars. This one is basically has inside an array of stars, and we'll push numbers inside this one, and then we are returning the array of stars. and then this one will display it and actually iterate all the stars, right? So let's see what we are pushing inside this array actually. We need to push first of all the x and y coordinate of the star. We're gonna add them randomly on the screen. That's one thing to push inside. And one way to do this one is to place x and y in a small object. So let's say let's start. It's a small object. Remember the object notation? We used to put it like that. We can put it also in the same line, it doesn't matter. And we'll have a property named x, which is a random number on horizontal. And we're gonna also have a random number on vertical, like that. So we are creating a star, and in AR stars, we are pushing this star. Right. So pretty simple logic here. So, and to display them, all we have to do, we have to iterate through the entire array. Let's say for let star of not stars, it's array stars. All we have to do right now is to say point. This is the graphical instruction to plot a point somewhere on the screen. We'll say point at star.x and star.y. The only thing we need to make sure that we have a stroke. Let's make the stroke outside. Stroke of white, because we need the points to be white. Stars are white, otherwise they are default black, and black on black won't be visible. So that's fine for now. Let's have a constant here, or let's have a variable stars is not equal empty array, but it's actually make stars. And let's have 100 stars for the beginning, which is good. And inside here, we should basically call display stars. Right. Display stars, let's run it. Oops. AR stars is not iterable. Which one? Oh, display stars, we need to pass the array that we need to basically display. So it's this one. We could have just looked into the global array, but that's how we did it. All right, so notice the small dots there. It doesn't look that dark anymore, right? It's much nicer. But let's make the stars move. And that will give the feeling that the spaceship is moving through the field of stars. So, yeah. So for this one, but before, let me move this logic here. The one that will remain loose here. This is update ship. Let's move it into an update ship, because this logic was all updating the ship. Update ship. And yeah, this should be, yeah. And now we are about to basically create a function update stars to make the stars move for each of the frames. So let's have another function here, update stars. And we can call it before display, we can call it after display. Some people like to play the display first and then do update the things. We can have it this way. It doesn't matter actually in this particular case. So let's create the function. So we have one make stars, the one that creates the star, one that displays it, and one that we're gonna update them. Function update stars. Okay, since we make this one take an argument, let's make this one takes an argument as well. And when we're gonna call it, we'll have to pass the argument. Otherwise, if we forget, we'll get an error again. So we are back here. Update stars. So what we want to do now is to change their X position and decrease it by a certain amount, by 3 pixels. And once they reach, let's say they move from right to left. And once they reach it 0, we make them jump at the end. All right. So let's iterate roll the stars again. And what we want to do, yes, star.x, we decrement 3 pixels from the X position, and we say if star.x is less than 0, then star.x equal 800. We just jump at the end of the screen. Let's see it. That should be all. Wow. Warp speed. We don't want warp speed. We just want normal speed. The reason is because we didn't clear the screen, right? So perhaps in display stars here, so we should clear the screen, or we should just have a clear screen here. Right, so if you are running it, yep. See, the stars are moving 3 pixels to the left, so it's looking from the reference point of view of the ship, is looking like the ship is moving actually, but actually the stars are moving to the left. The ship sits in the fixed position. Well, we can move also the ship if we want to, and now it looks like it's fixed, but if we want to go faster, we can also move the ship as well. But you know what? Let's make the stars move at different speeds, because at the end of the day, stars, when you look at the stars, hopefully they should move at different speeds because of the parallax effect. Some are further away, some are closer to us, and so therefore they should move at different speeds. So the way we're gonna do that, in the moment we create the star, we created like a small object of x and y. Let's have also a velocity. Each star will get at its creation time a velocity, which is a random number between 1 and 3. All right, and now when the stars are moving, we don't decrement by 3 pixels, but we're actually decrementing by the velocity of that star itself. So let's run it and notice the effect. And indeed, some stars are moving faster than others. It's looking like the entire space is more 3D than before. And I'm not sure if you see good on your screen. Let me just for a second, I like the star smalls, but let me increase the weight a little bit. So perhaps I should have a stroke weight of 2. Now they are thicker stars, and maybe these are good. These are nice, actually. It's not bad to have these chunky stars. We're designing kind of a retro game anyway. Whee! All right. Let me see if I can place something else here inside this program before we close it. So this is basically space race. That's an appropriate name. Let me see if I saved any other things together with my ship. Yeah, I have a few others. No. Let me pick an enemy just really quickly. Let's create a few enemies, and we'll not do the collisions, just to make them there for decor. All right, and that's it. So let's create here really quickly a function. Create enemies. And the enemies basically will have an img enemy. Let's name it enemy. We need to make up our mind when we basically design these variables or pick name for variables. Naming is important, but should not take too much time. And enemies, I'm also intending just for to make them really quickly, to design them off screen, somewhere to the right, and then assign them a velocity and let them just move by themselves. We are not handling collisions, we just let the engine move them. But let's see how they look like. So the X is basically a random number between 800 and, let's say, between 5 times more than 800. Kind of imagine 5 screens to the right. So we just pre-create all the enemy ships there, and on vertical it's a random number of 600 and zoom factor 3. Let's place this in how many enemies here, perhaps. Let's place this in a quick for loop. I++, just like that. We'll take the entire Sprite function here, and you know what, I don't even think that we need to add this and keep track them in an array, because we don't check for collisions. Let's just assign them some velocity, and that should do it. So enemy.velocity.x equal, and let's put a random velocity basically between -3 and -1. Some are moving faster, some are slower, just like this. And let's invoke the function. So maybe perhaps here, after we create the stars, we're gonna create 100 enemies, or maybe it's too much. 50? Let's say 100. Maybe it will be too crowded in the space. All right. So we have these enemy ships. Yes, there are too many. Let's create 50 of them. Doesn't matter. 100 star is good, but 50 enemy ship is better. All right. So here they are coming, and we are not checking for any collision. But you know, we can check for collisions, and then we can shoot at them, or if we hit one of them, we can just lose the game. All right. I just want to take it one more step. All right, one more step. So let's have here really quickly enemies, which is a new group. So again, this is equivalent to an empty array. And what I want to do after we create it, let's say enemies add enemy, like this, and we're gonna return the enemies, the group, and let's have the variable here enemies, create enemies. And now inside the loop we can check for collision, check collision. So we're gonna write this function really quickly here, check collision. So let's see what we have to check for collision. So we can check, we can say ship dot collide, and we're gonna say enemies, and then here we can say on collision. We can create a function named on collision, just like that, and we're gonna create it here. That takes as an argument basically the ship, and also takes the argument the actual enemy. All right. So first of all, print ln, or let's just say enemy remove. Let's say our ship is indestructible, and we are just crushing the enemies if we are hitting them. Yep. Boom, 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 boom. Boom, 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 boom. Boom, boom. Or what we can do, we can make our ship actually fall down if we are hitting. So we can say ship. Well, let's make it fall down, and that's it. We basically end for today. So we can say ship velocity dot y. Let's make it fall down, not up. So it's 10, and also ship rotation speed equal 2. Let's see the effect. So if you are hitting an enemy ship somewhere up, maybe rotation speed equal 5. All right. It's bouncing in these other ships. All right, so now you can see basically how you can turn this in a game, a really nice game, and you lose the game if you crash, you know, and if you pass all the enemy ships, perhaps you land somewhere safely. And yeah, so take this as a homework if you want to extend this one. And perhaps next time we can even build a game building project from scratch to finish. So this until now we just build elements. So let's put here space race. All right, so the program is on the chat there. And now with this one, I want to again thank you for watching, and I hope that you had patience during our lesson today. I'm gonna switch on the computer here and play my game. And for you, keep practicing, happy coding, and see you next time.